Good morning, everybody. Welcome to another example question. For this question, we will be doing Form 4, Chapter 3, Gravitation. Let's have a look at this question. As usual, if you want the PDF version of this question, you can just head down to the description box down below. All right. So diagram 3 shows the moon orbiting the Earth while the Earth orbits the sun. So you can see here, moon going around the Earth and Earth going around the sun. The gravitational force between the sun, Earth, and moon can be determined using Newton's universal law of gravitation. So the first question is, what is Newton's universal law of gravitation? Okay. Now, Newton's universal law of gravitation, right, is actually the formula. Yeah, the main formula in gravitation. If you look at your formula sheet, right, look at this formula right here. The first one, F equals to GMM over R squared. So if you can translate this formula into words, then you will get Newton's universal law of gravitation already. Okay? So let's have a look at this formula. Okay, I'm gonna write this down on our paper here. F equals to G M1 M2 over R squared. Okay, so let's try to write this into words. Now the first thing is we want to compare. The first thing is we want to compare the force and these two masses. Okay, so this M1 M2 is basically the mass of object number 1 and the mass of object number 2. Okay, so when we want to know the gravitational force between two things, you need to know the masses of these two things, and you need to know what is the product. Product means you multiply them together. Okay, so mass 1 multiplied by mass 2. If this number increases, then the force increases. If this number decreases, then the force decreases. Now, if you know this relationship, it's called directly proportional. Okay? So we can start by saying gravitational force between two bodies. Okay? So two things or two bodies, right? Is directly proportional to the product of their masses. Okay, again, just to explain to you one more time, product of their masses, that is mass 1 times mass 2. Okay, gravitational force, that is the F. So I'm saying these two things are directly proportional because if one thing increases, the other thing increases. If one thing decreases, the other thing decreases. Okay? So that's the first part. Now, the second part is R squared. This R is the distance between the two bodies. Now, not just the distance between the two bodies, actually. The distance between their center. From the center of one thing to the center of another thing. So let's say from the center of the sun to the center of the earth. That is R. Okay? Now, what's the relationship between the force and this R squared? So you can see R squared is at the bottom. If R squared increases, F will actually decrease. And if R squared decreases, F will actually increase. So what is this relationship called? That's inversely proportional. Okay? So we can say F is inversely proportional to the distance between their center square. Okay? Yeah? So I'm just going to continue with this sentence. Okay? I'm going to continue with this sentence. So I shouldn't have a full stop here. So I'm just going to say, and inversely proportional to the square. Okay? To the square of what? To the square of distance between their centers. Okay? The force is inversely proportional to the square of distance between their centers. Okay? So as you can see, right, if you want to write this whole thing, you actually don't need to memorize it because the formula is already available in the formula sheet. But you do need to know how to translate from formula to words. Okay? So these two things are directly proportional. These two things are inversely proportional. Okay, so don't go and memorize this very, very long definition. Okay, now what about the G? Why we never mention the G? Because the G is a constant. It's known as a gravitational constant and it can never change. So there's no relationship because G will never ever change. Okay, now next question. Based on the diagram 3, compare the gravitational force between Earth and Moon with Earth and Sun. Okay, so what is the gravitational force between Earth and Moon? And what is the gravitational force between Earth and Sun? Now, just by looking at this formula, we can again say that whoever got a bigger combination of mass, that's going to be a stronger force. So the Sun is huge. The Sun is very, very heavy. So Sun and Earth combo is definitely stronger than Earth and Moon combo. Understand? Okay, so we can say gravitational force between Earth and the Sun is greater than gravitational force between Earth and Moon. Okay? Yeah? Quite obvious, right? Quite obvious, right? Oops. 3 O's. Okay, now, of course, they asked to give the reason as well. Give a reason for that. And the very obvious reason is because the Sun is fat. Okay? Yeah, the Sun is very, very heavy. The mass of the Sun is greater than the mass of the Moon. Okay? Now, to be 100% accurate, you should say the product of mass between Earth and Sun is greater than the product of mass between Earth and Moon. But then, it doesn't really matter because both have the Earth inside. So actually, you only need to compare the Sun. That's why we don't have to write that. That's why we can write it like this also. Okay? Yeah? So, next question. Given all this information, the mass of the Moon, the mass of the Earth, the radius of the Earth, the gravitational force between Earth and the Moon, find the height of the Moon from the Earth's surface. Okay, now, just to make it clearer, right, I'm going to draw the Earth and the Moon out. Okay, when you want to know the gravitational force, we got to use the formula F equals to G m1 m2 over r squared. I told you just now, this r, right, is the distance between what? It's the distance between the center. So from here to here, okay? From center to center. But they want us to find what? They want us to find the height of the Moon from the Earth's surface. When you measure from the Earth's surface, you're only measuring from here to here only. Okay? Only starting from here. So this is what they want, the h. That is why they gave you what? That is why they gave you the radius. This is the radius of the Earth. From the center to the surface of the Earth. Okay? That's the radius. So later, when you find the r, you will find this whole thing, okay, the blue color line. Then you can just minus off the radius to get the height. Okay? So everything is basically given to you already. So just write down the gravitational force, 2 times 10 power 20. Okay? G is 6.67 times 10 power negative 11. This one. And then mass 1, you can just use whichever. Doesn't matter. So mass 1 will be, let's say, the Earth. Mass 2 will be the Moon. okay, divided by r squared. Okay, yeah, divided by r squared. So now you can find what is r. Okay, yeah. Let me get my calculator first. Okay, so I can do it. I can do this right now. 6.67, 10 power negative 11 times 5.97 times 10 power 24 times 7.35 times 10 power 22, and then divided by 2 times 10 power 20. Okay, so that is r squared. If I square root this, I will get 382,541,674.2 meters. Okay, so now I just have to minus, like I said just now, once you get the r, you can minus the radius. Okay, that will give you your h. So 382,541,674.2 minus 6.37 times 10 power 6. Okay, 6.37 times 10 power 6. And that will give me an answer of 376,171,674.2 meters. Okay, so that would be the height of the moon from the Earth's surface. Okay, let me know if you couldn't get the answer. Yeah, I will give you a step-by-step guide in the comments lah. Okay, so if you learned something, make sure to like and subscribe, and let me know if you want to see any other exercise for any other chapters. Okay, just let me know in the comments below. I'll see you next time. Bye bye.